Thank you for clicking on this video to look at laws of exponents and some examples. All right. Let A and B be any real numbers, and let M and N be any integers. So considering the laws of exponent, I'm going to be using A and B, which are real numbers, and M and N, which are any integers. So if A is not 0, that is A is different from 0, if it's a real number and N is a positive integer, N is a positive integer, then what follows? So if A raised to the power of 0, then it is 1. And if we have A raised to the power of negative N, we can write it as 1 divided by A raised to the power of N. We are going to be making use of these ideas as we proceed. So let us consider the first rule, or the first law of exponents. So if we have A raised to the power of M multiplying by A raised to the power of N, then the law says that since these bases are the same, that is, we have A here and we have A here, then we are going to pick one, then we add the exponents. So A raised to the power of M times A raised to the power of N is A raised to the power of M plus N. For example, if we have, let's say, 3 raised to the power of 2 times 3 raised to the power of 4. So since we have the same base, then we can say this is 3 raised to the power of 2 plus 4. And that is 3 raised to the power of 6. So that is that. The second rule, well, if this is multiplication, then we can have that of division. So A raised to the power of M divided by A raised to the power of N, which is A raised to the power of N. So in this case where we add the exponent, so for the multiplication, so for division, we are going to subtract the exponent. For example, suppose we have, let's say, 3 raised to the power of 4 divided by 3 raised to the power of, let's say, 2. So what the rule or the law is saying is that we take a base because they are the same, then we subtract the exponent, and that is 3 raised to the power of 2. Moving on, let us consider the third rule or the third law, which says if we have this real number A and we raise it to M, and now this A raised to the power of M, we are raising everything to N again. So look at the difference between this and what we have here. So what this law is saying is that we can multiply this exponent, that is, we multiply the powers, that is A raised to the power M times N. That is what we have. And for example, if we have, let's say, if we have 3 raised to the power 2, then everything raised to the power of 5. What the law is saying is that we can take this 3, then we multiply the powers or the exponent, which is 3 raised to the power of 10. All right. The fourth rule of exponent says that, so now suppose we have A times B, everything raised to the power of N. So look at this. We have A multiplied by B. We have A and B, different bases. So what this law is saying is that we are going to have A raised to the power of N times B raised to the power of N. For example, if we have 3 times 4, everything raised to the power of 2, the law says we can raise this 3 to power of 2 times 4 raised to power of 2. So let us leave it there for now. The fifth rule, if we have A divided by B and we raise everything to this positive integer n, now what this rule is saying is that we can open up this by saying A raised to power of n by B raised to power of n. As a quick example, so if we have 3 divided by 4, everything raised to power of 2. What this is saying is, you can say this is 3 raised to power of 2 divided by 4 raised to power of 2. So again, let us leave it there for now. We may need to simplify it in our subsequent examples. So the sixth law, so let us do something here. We have A raised to power of, A divided by B, now raised to power of negative exponent. So this is going to give us A raised to power of negative n, just like we did here, divided by B raised to power of negative n. But let us see what we can do in this case. Well, the law says we can, if we want to ensure that this negative integer becomes positive integer, then what we can do is to, reverse or invert this, and we have B raised to power of n divided by A raised to power of n. A quick example is if we have, let's say, if we have something like, say, 3 divided by 5, everything raised to power of negative 2. Then what the law is saying is that we can just invert this, 5 divided by 3, then we make this to become positive. So that is 5 raised to power of 2 divided by 3 raised to power of 2. All right. And the seventh rule, if we have A raised to power of negative n divided by B divided by B raised to power of negative n. Well, again, what we can do is that this is B, this becomes B raised to power of positive m divided by A raised to power of n. How do I know that this will work? Well, if we come back to what we have here, A raised to power of negative n equals to 1 divided by A raised to power of positive n. Let us consider that in this case, I will change this. So A raised to power of negative n is what? 1 by A raised to power n. And let us see this. B raised to power of negative n is again 1 by B raised to power of m. And what we then have, do not forget this is A raised to power of negative n divided by this, which means we have 1 over A raised to power of n divided by 1 by B raised to power of m, which is 1 by A raised to power of n times B raised to power of m divided by 1, which is B raised to power of m by A raised to power of n. So we can see that this is exactly what we have here. And as a quick example, if we have, let's say, 3 raised to power of negative 2 divided by 4 raised to power of negative 3. So what that is saying is that we can, because of this negative, we can say this is 4 raised to power of 3 divided by 3 raised to power of 2. And we can arrive here. All right. So let us make use of all these laws of exponent in some standard examples. So I will consider example 1. So let us consider some examples. So example 1. Suppose we have x raised to the power of 3 times x raised to the power of 4. Well, we can see that this is exactly like what we do have as our rule number 1. And that is x. So since we have the same base, x, and it is multiplication, then we pick one of the bases, which is, well, x, then we add the exponent, and that is x raised to power of 7. And so let us call this A, B. So if we have, let's say, y raised to power of -2 times y raised to power of 7. Again, the same base, so we are still making use of rule 1, and this is multiplication. So we pick this, then we add the powers, that is -2 plus 7. And this is y raised to power 5 minus 2 plus 7 will give you 5. All right, so the next one under our first example, if we have, let's say, 2y squared raised to power of 3. So I want you to look at this very well. So we have 2y raised to power of 2, then everything raised to power of 3. Then we will see how that is similar to what we do have here. However, it is also similar to what we do have here, because we have a times b. Here as well, we have 2 times y raised to power of 2. So, which means here we need to apply law number 4 first. That is, we do something like this. Okay, in this case, that means we will have 2 raised to power of 3 times y squared. Then do not forget that also will be raised to power of 3. And that is 2 raised to power of 3 will give us 8. That is 2 times 2 times 2. And this now, if we remember what our third law says, that if we have this, then we can multiply the powers. So in this sense, we can say this is y raised to power 2 times 3. And that is, now we have 8y raised to power of 6. And that is our answer. All right, let us move on to example 2. Example 2, okay. Suppose we have, let's say, x raised to power -2 and x raised to power -4 and x raised to power 5. Our law can be applied to more than when we have 2 instances, when we have just 2, like a to the power of m times a to the power of n. Right, so in this sense, all what we need to do is to apply the first law. How do I know I'm going to use the first law? Well, what we have here is multiplication. So what do I need to do? I will pick one base, which is x, then I will add all the powers. That is -2 plus -4 plus 5. And that is x raised to power -2. Well, if you distribute this, you have -4 plus 5. And that is x raised to power -6 plus 5. Because -2 minus 4 is -6. So plus 5. So that is x raised to power -1. But let me achieve something. I want to ensure that this is in positive exponent. So I can say this is 1 by x. If you have not forgotten, we have it here. So if it is a raised to power -n, then it is equal to 1 divided by a raised to power of n. So which is what we have here. Okay, so second example, let us consider another example here. Suppose we have something like x raised to power of 16 divided by x raised to power of 10. Well, we know that is division and they have the same base. So that is the first thing you need to look out for, the same base, x and x. So that is x raised to power 16 minus 10. Because this is division, so you subtract the exponent. And that is x raised to power of 6. So since this is a positive exponent, I will leave it like that. All right. So let us move on to another, to example 3. Let us move on to example 3. So suppose I have something like a raised to power of 8, then times a raised to power of negative 2 divided by a. What do I need to do in this sense? Well, very simple. It's like I'm going to combine two laws to solve this problem, and that is equal to. So we can see that we can apply the first law to undo the numerator sign, and that is a raised to power 8 plus negative 2. Because this is multiplication, then you need to add the powers, divided by a, and that is a raised to power 8. If you distribute this, positive times negative, you have negative 2 divided by a. That is a raised to power 6 divided by a. And do not forget that this is a raised to power 1. And now this is division, right? The same base again, a and a. So what we have to do is to say a raised to power of 6 minus 1. And that is a raised to power of 5. And that is our answer. All right, so let me call this the first one there, a. And let us look at another example there. So suppose we have a problem like this, a raised to power of 2, a raised to power of 4, then everything raised to power of 3. Again, we will see two laws coming into play here. First, we have same basis inside this. So you may say, oh, can I just, apply the apply rule number 4 first? Well, whichever way you go, you are still going to get your answer. But since I have the same base here, I can first apply rule number 1 to make my work simple. So this is a. Since I have the same base here and this is multiplication, then I can add the powers for this inner part. Then I have this, and this is a raised to power 6, everything raised to power 3. Now I can apply my third law, and that is a raised to power 6 times 3. And that is a raised to power of 18. And that is my answer. All right, moving on. So let us consider another example there. Suppose we have x divided by 2 multiplied by 5x to the 6. So how do we undo this? Well, equals to what we can see here. Let us take it one after the other. This is like x over 2 times 5 times x raised to power 6. Again, we can see our x is somewhere. But then we have divided by 2 here. I can separate this to be 1/2 times x times 5 times x to power of 6. So now you can see the x's very well. So this is, since this is multiplication, then I can say this is 5 by 2 multiplied by x. Remember again that this is to power of 1, right? So that is 1 plus 6, right? The powers, the same base, then you add the powers, right? So what do we then have? That is 5 divided by 2 times x raised to power of 7. So this is the best way we can simplify this. Then we can leave it as that. All right, moving on. Let us consider example 4, where getting more and more complicated. So if we have 8m raised to the power of -2, then n raised to the power of 4, and we multiply, so let us call this the first one, and we multiply this by something like half times n raised to the power of -2. Well, how do we solve this? So let us use the same approach as we had under example 3c. So can I just say this is 8 times m raised to the power -2 times n raised to the power 4 times 1/2 times n raised to the power -2. Yes. How do I know I can do that? Because this is just 1 and this is just 1. So I can just open up like that. All right. So this is 8 times 1/2, which I can say this is here 1, then here 4. So in this place, I have 4. Now, we have m raised to -2 times n raised to 4 times n raised to -2. We only have a single m here, then let us leave that. So that is 4m raised to -2 times, in this case, we have the same base n, right? So what do we do to the powers or the exponent? We add them. So that is n raised to the power 4 plus -2. And again, we have 4m to -2. Then n, this is 4 minus, because plus times minus is -2. And now what we do have is 4m raised to -2, n raised to power 2. Let us try to ensure that we only have positive exponent. So this is, so do not forget, by now you should be able to write this. So this is 4 times 1/m squared times n squared. And that is 4n squared by m squared. And that is our answer. All right, so let us consider another example under number 4. Let us consider a situation whereby we have a problem like this: 3a raised to the power of 4, b raised to the power of -2. But in this case, everything is raised to power of 3. Then we have another stuffs here. So can I just move out the way I did here? No, I would not do that in this case because of these 3. So what do I need to do? Well, I can apply rule number 4 by saying this is 3 raised to the power of 3. Remember, it must affect everything inside. Rule number 4, a raised to the power n times b raised to the power n. So it has to apply to everything inside. So then a raised to the power of 4, do not forget that you have to raise it to this 3. Then b raised to the power of 2, do not forget you have to raise it to this 3. Before you have a raised to the power of 2, b raised to the power of 1. Well, everything, multiplication there, equals to, this is 27, 3 times 3 times 3. So if you apply rule number 3, then this is a raised to the power 12, because this is 4 times 3. And this is b raised to the power -6, -2 times 3. Then times a raised to the power 2 times b raised to the power -1. So at this point now, you can bring some things together. This is 27, put it there. This is, then remember, everything here is multiplication, so you can use your rule. So a raised to power 12, this is a raised to power 2. So remember, you have to add because this is multiplication, and remember, you have the same base, a and a. Then what of when we have b? Well, when we have b in this case, we have multiplication in between as well. Then what we need to do is to add the powers as well. So minus 6 plus minus 1. All right. So equals to 27, a raised to power of 14, then b raised to power of negative 6, plus times minus is minus 1. So that is 27, a raised to power of 14, b raised to power of negative 7. So let us try to write this in a way that we have just positive exponent. So that is 27, a raised to power of 14 times 1 by b raised to power of 7. You know why that, how we can write that by now. So that is 27, a raised to power of 14 by b raised to power of 7. So if you have forgotten how I got this part from here, just quickly go back to what we have here. Just quickly go back to what we have here. Then you will remember why we can move from here to here. All right. Another example. Let us move on to another example. Example 5. Okay. Example 5. So let us have this problem. X raised to power 4, z raised to power of 2, divided by 4, y raised to power 5. Then we are multiplying everything here by 2x raised to power of 3, y raised to power of 2 divided by z raised to power of 3, and everything raised to power of 2. This is interesting, isn't it? So let us call this one the first problem we are solving here. And I will tell you that this is also similar to what we have been doing. Well, in this case, let us consider the first stuffs here. This is x, this is z, this is y. It looks like we cannot combine anything here. So let us just rewrite everything we have in here. Let us rewrite. Maybe we will be able to do something here. Oh yes, although we cannot combine stuffs here, but let us see, we can, apply one of our laws here and move on from there. So remember, this we apply to everything inside. So that is 2 raised to power of 2, x raised to power of 3 raised to power of 2, y raised to power of 2 raised to power of 2 by z raised to power of 3 raised to power of 2. As time goes on, you will not need to be writing this. You just do it directly. But for the sake of explanation, I want to go through that. So x raised to power of 4, z raised to power of 2, 4y raised to power of 5. So multiply by, let me put my parentheses. So this gives us 4. Then x, you remember the rule you are going to apply now. So you multiply the powers, so you have 6. Then y raised to power of 4 divided by z raised to power of 6. So now let us see if there is something we can do here. Well, now you know there is multiplication in between here. These two stuffs, rather. Then you would see we have x here, we have x here, we have z here, we have z here. This looks like division, right? Z raised to power of 2, z raised to power of 6 at the denominator sign. And here, there is y here, there is y here. So let us apply our laws to this. So this is x, and there is multiplication in between. So you can just say this is x raised to power 4. Then you remember we are going to add the exponent. There is a 4, which is a coefficient of this guy here. The coefficient of what we have here is 1. Here is 4, so that is 4. What of z? For z, that is z raised to power of 2. But because this is done, it is at the denominator. That is, it's like we have something like z raised to power 2 divided by z raised to power 6. So you know how we are going to undo that. So that is z raised to power 2 minus z raised to power 6. Again, so what of our y? So we have y raised to power of 4 here, then y raised to power of 5. Again, you know, just like this, so this is minus 5 because it is division. Y raised to power 4 divided by y raised to power of 5. Divide by what? Remember, we have 4 here. Well, one thing you can do is that you can have, you could have cancelled this out here. But it's still okay. So this guy takes care of this guy. And what do we have left is x raised to power of 10. We have x raised to power of 10. X raised to power of 10. What of z? Well, that is negative 4. And our y is negative 1. So let us try to write everything in positive exponent. So that is x raised to power of 10. It's positive. Then this is, so you just throw everything on that. So that is y, then z raised to power 4. And that is our answer for that problem. All right. So let us consider another example under example 5. Let us say we have rs squared, everything raised to power 3, divided by r raised to power negative 3, s squared, then everything raised to power of 2 here. So how do we handle this? By this time now, you know that we cannot combine these two inside, but we can apply one of our laws over this. So that is r raised to power of 3, then s raised to power of 6. By now, you agree with me that because this is power and this is power, so I'm applying my law number 3, I guess, to have this s raised to power of 6. And divide by, again, I cannot combine r and s, so let me apply this. So that is r raised to power negative 6, then s raised to power 4. So this now gives us what? So we now have r raised to power 3, r raised to power negative 6. Well, you know what we can do now. So that is r raised to power 3. If this remember, this is, okay, so let me show us very well. So this is r raised to power of 3 divided by r raised to power of negative 6, s raised to power of 6, s raised to power of 4. So that is r raised to power of 3. This is division, so you need to subtract the powers, right? Times s raised to power of 6, so you subtract the powers. So this is r raised to power of 3. Negative times negative is positive, so you have that. Then s raised to power 2. So that is r raised to power 9, then s raised to power 2. So this is our answer for this problem. And let us consider a last example, example 6. Let's take the first one there to be 5x y raised to negative 2 divided by x raised to negative 1 y raised to negative 3. Okay, so what we can do again is to say 5, this is x and this is x. So again, I can say this is, remember this is raised to power 1. So if this is coming up, so let's do it this way. So because this is division, so that is minus, I will subtract the powers. But do not forget, this is -1. Then y raised to power -2, which is already here. Because this is division, minus, then this guy is -3, right? So I've brought everything up. So that is 5x raised to power 1 plus 1, then y -2, minus times minus, that is plus 3. So that is 5x raised to power 2, then y -2 plus 3 will give you 1. So we can say our answer is 5x squared y. So that is our answer for that problem. And lastly, let us consider this example: 2a raised to power -1b divided by a squared b minus 3, then everything raised to power -3. Well, is there a law that we can make use of? Is there a law that we can make use of from number 1 to 7? Well, there are a couple of ways I can undo this, but let me try to see if I can undo the stuffs inside first, if I can combine some stuffs inside. Yeah, it looks like I can, because I have a here, I have a here. So by now, I'm going to just tell you that, well, this is 2, then this is a raised to power -1. So you would have seen that in this case, when this guy comes up, if it is negative, then it becomes positive here. You would see that. And if it is negative, it becomes positive here. And if it is positive, it will become negative when it gets to the numerator side. So which means this +2 becomes -2. And b, which is to power of 1, then bb, so this is -3, it becomes +3 when it comes up. Or you use the number when you are dividing, that is, this is what I mean, b divided by b raised to power -3 is b raised to power 1, then you subtract the powers, the exponent, so -3. So that is b raised to power 1, minus times minus is +3. So that is b raised to power of 4. So in this sense, do not forget that you have this guy out here. You are just trying to combine this inner part. So this is 2a raised to power -3 minus 1 minus 2 will give you -3. Then b raised to power 4. Then everything raised to power of -3. So in this case now, you can do what? Then you can apply law number 4 to this, and which is 2 raised to power -3. Remember, you apply it to everything you have there. A raised to power -3, then times -3, then b raised to power 4 times -3. So that is 2 raised to power -3, a raised to power, so minus times minus is plus, 3 times 3 is 9. So b raised to power 4 times -3, that is -12. Looks like we can make some things become positive exponent. From our starting point, you would agree with me that this will be 1 divided by 2 raised to power 3, then a raised to power 9, then times 1 divided by b raised to power 12. And that is 1 divided by 8, a raised to power 9, times 1 over b raised to power 12. And that is a raised to power 9 divided by 8b raised to power 12. And that is our answer for that problem. So at this point, I would like to stop this video here, and I hope that you have been able to understand how we can apply the rules of exponent in solving some problems. So thank you for watching to the end, and I hope that you come back to look for my subsequent videos. Next video, I'm going to be considering radicals and exponent. So thank you, and do not forget to subscribe to this YouTube channel so that you'll be able to get updates.